component which is parallel to B, we will call it the longitudinal component of the velocity u, and the component which is perpendicular to B, we will call it the transverse component to the of the velocity u. So u can be resolved into two components, ut and ub. So you can see, sorry, ut and ul. Ul is longitudinal component, ut is the transverse component of u. Now, when a charge is in motion in electric field, then you know there is a law, it obeys that law. Law is called the Lorentz equation. We find out the force that is experienced by the charge. And what is the force that is experienced by the charge is Q into u cross B. If it is in a vector field, if it is in a magnetic field, so it will be u cross B into Q. Q is the charge that is moving, u is the velocity of the charge, and B is the magnetic field. So this is Lorentz equation. Since this is a force equation, the force will be equal to mass into acceleration. So mass of the charged particle is m. So m into acceleration, you know, is du by dt. So our time derivative of the velocity is u. Therefore, it will be mass into acceleration. Therefore, the final equation is F, which is Q cross B, which is again equal to mass into acceleration, or m into du upon dt. Now, as we saw that the velocity is not along B, we have decomposed it into two components, ul and ub. Ul is the longitudinal component which is parallel to the magnetic field, and ut is the transverse component which is perpendicular to the magnetic field. Therefore, we can write this equation, q u cross b is equal to m du by dt. That we can write as q ul plus ut. In place of u, just replace u with ul plus ut. So that gives me the second equation, q ul plus ut will be equal to q ul plus ut cross b will be equal to m du by dt into ul plus dt. Now let us take a special condition. We discussed this, the situation that we discussed, of the picture that you see is the generalized condition. We will consider a special condition here, then I will leave it to you to generalize it. So in the special condition, what happens is a magnetic field B is oriented along this z axis. So B is equal to g cap B0. B0 is the magnitude and g cap gives you the direction. So magnetic field is along the z axis, B is equal to B0 and g cap. Now the moment magnetic field is along the z axis, UL will also be along the z axis. So UL will be UG z cap. So that gives you the UG gives you the magnitude of UL, longitudinal component, and g cap is the direction of the longitudinal component. Since B is along g cap and along the z direction, UL will be also along z direction. Now what happens to UT? We said that UT is perpendicular or transverse to UL. UL is along the z direction. Since B is along the z direction, UL is along the z direction, which means UT can be in the x direction, or UT can be in the y direction, or in general it can be in the xy plane, because xy plane is transverse to the z axis. Therefore, we can write UT in its component forms in terms of x and y. So ut will be ux x cap plus uy y cap. So now we have generalized it, or we have got a particular situation. From generalized situation, we have come to a particular situation. Now in this particular situation, let us find out what will be dux upon dt and duy upon dt. Now how to find that out? Dux and duy, they together combine together to give us ut, and we know what will be dut by dt. Dut by dt will be dux by dt x cap plus duy by dt y cap. Now dut by dt, that comes from Lorentz equation, that we can write as q into ut cross b that divided by m. That comes from the above equation. Q ul plus ut cross b is equal to m d by dt ul plus ut. So take each component of the vector, each separate component or each vector. If I take each vector, then I get q ut cross b is equal to m d by dt ut. From that we take the each component, again x component and y component. From that you will get dux by dt is equal to q uy b0 by m. Similarly duyt and duy upon dt will be minus q ux b0 by m. Now in these two equations, you can see that on the right hand side there is a term which is common. That term is q into capital V0 by m. That is common to both these equations, dux by dt and duy by dt. To both these terms, that term is common. So let us define that as gyro frequency and write it as omega h. Omega h is the gyro frequency which is common to dux by dt and duy by dt, and that is equal to q b0 by m. Now why we are calling it gyro frequency, that you can easily find out if you put the dimensional analysis. So make a dimensional analysis. Q b0 by m, its dimension will be 1 upon t. Since it will be 1 upon t, 1 upon capital T is the dimension, mlt. So from that you get a t. So q b0 by m will give you 1 upon t. 1 upon t is frequency. Therefore we call it gyro frequency. It's dimensionally omega h is equal to frequency. So we call it gyro frequency. So omega h will be q b0 by m, and you know b and h, they are related by a relation mu 0 h is equal to b. Therefore b0 will be mu 0 h0. So put that in the gyro frequency, that gives you omega h is equal to q mu 0 h0 by m. So this is how you define gyro frequency. Now we know that the transverse component has two components. Transverse part has two components. One is ux, one is uy. Let us define a term zeta as ux plus juy. So I will take the imaginary part of y, add that to real part of x. Then I get zeta. So if I define zeta in that manner, and then what I will get is d psi by zeta plus j omega h zeta is equal to 0. How I am going to get it? That is the question. Now you know dux by dt is equal to omega h omega h uy, and duy by dt is equal to minus omega h ux. Now let us add these together. Say dux by dt plus j duy by dt. That you can write as d by dt of ux plus j uy. Ux plus j uy we have defined as zeta. So that gives me d zeta upon dt. So d zeta by dt, that first term comes. Then the second term comes from this form. Omega h uy, that remains as it is. Then minus omega h ux into j. So minus, if I do that, minus omega h minus j omega h ux, then let us add these two. If I add the right hand terms, take omega h common. If I take omega h common, within bracket I am going to get uy minus j ux. From that, let us take j common. Minus j common. If we take minus j common, that will give us minus j omega h into omega x plus j uy. So ux plus j uy, that is zeta. So we get on the right hand side minus j omega h into zeta. So bring everything to the left hand side, that gives d zeta by dt plus j omega h zeta. Right hand side will now become 0 because everything we have put on the left hand side. So d zeta t plus j omega h zeta is equal to 0. This is the first order differential equation. We can easily solve it. You know, solution of this first order differential equation will be of the form ut zeta will be of the form ut e to the power j omega h t. Just a minute. Now that we can expand ut absolute value, that we can expand. Why I have taken ut absolute value, that also you can easily see this. The solution will be of the form some constant into e to the power j omega ht. That constant will be equal to ut absolute, and that you can easily find out at the moment t is equal to 0. This is equal to 0. Everything is 0. Put that value. So from that you will get. At the moment t is equal to 0, it has not started moving in the magnetic field, but it has a velocity of ut. Therefore, that will be ut absolute. So ut absolute comes from that part. Then e to the power j omega ht, that is cos omega ht plus j sin omega ht. Now let us use this value further. So if I go further, just from that we are starting. Let us write the component forms. Zeta is equal to ux plus j uy. So from this, if we equate the real part and the imaginary part, from the real part we will get ux. Ux is defined as the dx by dt. You know, the velocity is time rate of change of displacement. So ux is equal to dx by dt. That will be, by equating the real parts, that will give you ut cos omega ht. Similarly, equating the imaginary parts, we will get uy, which is equal to dy by dt, that will be equal to ut sin omega st. These are again first order differential equations in x and y. So we can find out what is x and what is y. So x will be equal to x will be equal to some constant plus ut and sin omega st plus a phase term. Similarly, uy will be equal to some constant plus ut cos omega ht plus a phase term. So this is about ux and uy. Now what about ug? Ug will be dg by dt, that is equal to ul, because we have said that the magnetic field is along the z direction and ul is also along the z direction, which is the longitudinal component of the velocity. Therefore ug will be equal to ul, ug will be equal to dg by dt. Now this is also a first order differential equation, so g will be equal to some constant plus ul into t. Now using these relationships, by solving the equations as I told you, now x minus x0 is the constant. I told you it on the right hand side, bring the constant to the left hand side. So x minus x0 will be ut by omega h sin omega ht plus phi by integrating the first equation. By integrating the second equation, you will get y minus y0 is equal to ut by omega h cos omega ht plus phi 0. And from the third equation, you will get j minus g0 is equal to ult. Now consider the two equations for x and y. Now you see in the x and y, backward. In the x and y, one is x minus x0, other is y minus y0. If I take the square of those two, x minus x0 square plus y minus y0 square, that will be equal to ut square by omega h square or ut by omega h square. You know x minus x0 square plus y minus y0 square is equal to r square is the equation for a circle. Therefore, these two equations, x minus x0 and y minus y0, they give us a circle whose radius will be equal to ut by omega h. So ut by omega h is the radius of a circle for which the center is at x0, y0. Now let us call this radius as the Larmor radius. So let us define Larmor radius RC as ut upon omega h. Now what does this radius give? This is the radius of the circle given by the equation for x and y. Then what is x0, y0 and g0? These are the constants of integration, and the x0 and y0 are at the center of this radius. Larmor circle radius is x0, Larmor circle radius is rc ut by omega h, and the circle is the center is at x0, y0. And now you can see, as I told you or as we discussed, you can see first the picture here. What is the picture? Shows you x, y, z direction, that is the coordinate system. Then a circle of radius rc at a distance r from the origin. We are considering the a point on this circle. Now at that point, at any point on that point, then you will get ul, which is along the z direction, that you can see, and ut is in the xy plane, is parallel to the xy plane, is in a plane which is parallel to the xy plane. So ut can be of the form ux plus uy, that form it can get, and total u is, you can see this is the total u is in that particular direction, which is the vector addition of ul ut. So we started from that, we ultimately reached to that point. So this is easy to understand. Then what happens is the particle starts moving because of the application of the field. The particle starts moving. the particle will move along the z direction, which means the circle will move along the z direction and the center will move along the z axis, right? So the particle, when it is moving in the magnetic field, its characteristics will be that it will rotate around the magnetic field line in a circle which is called the Larmor circle of radius rc at a frequency, with a frequency omega h. That is one characteristic. Other is, since it is moving, the center is moving along the z axis, a circle, imagine a circle whose center is moving along the z axis. If the circle moves along the z axis with its center constantly along z axis, then it describes a helix. Therefore, this motion will describe a helical path. So it will trace out a helix with velocity ul. It is moving in the z direction with velocity ul. So it is tracing out a helix with velocity ul, and its axis is always on the z axis, and the star is always on the z axis. So center of the circle is always along the z axis. So axis is determined by the center of the circle. So if it is not in the z axis, it can be in any direction. Then also it will describe a helical path, and the axis of the helix will determine the center of the circle always. So this is basically what I wanted to tell you initially. This you are expected to have learned earlier. So, and now let us see why we read this. What is the advantage? What was the thing, or application for which we discussed this? Then we'll go to the application. And now please remember that the force on a charge is proportional to gradient of the magnetic field, that we have already seen. So since the force on the charge is proportional to gradient of the magnetic field, we can write F as equal to gradient of magnetic field grad V and into a proportionality constant, which is M, capital M, magnitude. And why I am taking a negative sign here, that you can see in a moment when we go to the next slide or the next lecture. There you will see why we have taken a negative sign. Actually, this force is acting in the negative direction. If the direction of the M is G, minus G, then force is along G. Because of that, we are taking a negative sign. So minus capital M and grad B. Minus capital M mod grad B. So that will be equal to, as we have discussed, mass into acceleration m du by dt. Now what is m, capital M? That is defined as little m, which is the mass, into q square into rc into b divided by 2m. That is the magnitude of the magnetic dipole moment. Alright. So capital M is the magnitude of the magnetic dipole moment. Now your question will be, from where we are going to get this dipole, because of which we are getting a magnetic dipole moment. Like you have already seen in your basic courses that if we have a dipole, whether it is electric dipole or magnetic dipole, then it will have a moment, electric dipole moment, which is q into dl, or a magnetic dipole moment, which will be m into this value dl. Now from where we get this magnetic field, etc., that we get this magnetic dipole moment. For magnetic dipole moment to exist, there has to be magnetic field, right? You know, the earth has a magnetic field. we will discuss how, from where we get this magnetic field a little bit. But Earth has its own magnetic field, and this magnetic field is not homogeneous. Why? Because of the structure of the Earth. Earth is not a proper sphere, pure sphere or accurate spheres. It is not spherical. It is like a squeezed sphere. Like you take an ellipse and rotate it, so you get an ellipsoid. Earth is mostly like an ellipsoid, which is approaching a sphere. So because of that structure, its magnetic field is not homogeneous. At the pole it will be different, at the equator it will be different. The magnetic field is the strongest at its pole and weakest at its equator. So at the poles, the flux lines conserve. Magnetic flux lines conserve at the pole, at the south pole and at the north pole. From there the flux lines come out, emerge out or diverge out, go through the equator and again converge on the north pole. So from south pole to north pole or north pole to south pole, and that is what happens. Now for conservation of energy, so that is a note about the magnetic dipole because of the Earth. Now for conservation of momentum or conservation of energy, we must have half mv square is equal to a constant. Now you know what is half mv square, that is kinetic energy. Kinetic energy has to be constant. We are saying conservation of momentum, and it is really, I am relating it to kinetic energy, from where we are getting this. Now you know our kinetic energy is half mv square. Differentiate that with respect to time, so it will be half m dv square by dt. dv square by dt is dv square by dv, dv by dt, right? So from that you get the right hand side, half dv square by dv, half dv square by dv, 2v, right? So from that you get cancel out half by 2, so that becomes mv, which is the momentum, right? So from that we are saying that if the energy is conserved, momentum will also be conserved. So for conservation of momentum, why we are considering momentum? Momentum comes from the motion. Earth is rotating and Earth is revolving around sun. Earth is rotating around its axis. Therefore, there has to be a momentum which is conserved. If it is not conserved, it will stop rotating. So momentum has to be conserved. For conservation of momentum or conservation of energy, half mul square cross uh square has to be constant. Now as b will increase, omega h will increase and omega ut will increase. Why? We have already seen the relationship between omega h and b. B increases, omega h increases. Similarly, we have seen the relationship between b and ut, omega h and ut. So as they increase, ut also will increase. So as b increases, these are going to increase. So they will be maximum at the pole, omega h and omega t. Ut will be maximum at the pole and minimum at the equator. So this is one point that you should remember. This comes from conservation of momentum. Then again, as b increases, we also have seen that Rc decreases. So b will increase, Rc will decrease. If Rc will decrease, the other part remains as it is, ut keeps on increasing. So these two are the inferences from the conservation of momentum. Therefore, ut increases with convergence of flux line. What does that mean? Ut will increase with conservation of flux line. What does that mean? How this is occurring? Because conservation these flux lines, they converge at the pole, and at the pole B is maximum. We have said that B is increasing, and which is resulting in increase of UT. Therefore, UT increases with conservation of convergence of flux lines. So this requires decreasing UL for conserve momentum. So to conserve momentum, if UT is increasing, UL has to decrease. Otherwise, energy will keep on increasing, energy cannot be created, so energy cannot increase, it will not remain constant. Half MUL square plus UH square will not remain constant if both of them increase. And therefore, UT increases, requiring UL a decrease in UL for conservation of momentum. Okay, so from that let us come to this part, Earth's magnetic field. Earth's magnetic field has three components. And the first component, or the dominating field, is due to the outer core, the surface of the Earth, to the portion. It has three portions. So I am not going to consider all the three portions. We will consider the outer core only. This outer core is by cooling down of liquid metals or molten core. So since it contains metallic elements which is rotating only in a field, in a magnetic field or electromagnetic field also, the metallic element rotating in electromagnetic field. From where electromagnetic field comes? Can be your question. It comes from sun, because sun is there, sun is radiating always light. Light is the form of an electromagnetic field. So Earth is within, all the planets are within electromagnetic field. So as the Earth starts rotating, it is rotating within a electromagnetic field. And you know, if you take a conductor, rotate it in the electromagnetic field, that is going to give you magnetic field. So it gives a dynamo effect and gives a magnetic field. Approximately, since it is rotating continuously, it is approximately like a dipole field. And the magnetic dipole, this magnetic dipole will is pointing towards south. How you know that it is pointing towards south? Put a magnetic needle on any place in the Earth, its north pole will align towards the north pole of the Earth, and the south pole will align towards the south pole of the Earth. From that, you see that its magnetic dipole is pointing towards south. Okay. Then the second component is fields due to Earth's crust and the upper mantle. Okay. Then the third is atmospheric magnetic field from the currents in the atmosphere and currents in the sea. So atmosphere and ocean. From that we derive magnetic field. We are not going to consider how they come. Everything, those details are not required. They are beyond the scope of your course at this point, unless you are going to work in the atmospheric region or pure propagation. Unless you work in that area, it is not required. Now let us take two constants. As I told, at the pole it is maximum, at the equator it is minimum. At the pole, and the magnitude of magnetic field, Earth's magnetic field, is 0. And at the equator it is less. You can see it is 0.25 into 10 to the power minus 4 Tesla. So these are the two values, approximate values at pole and equator, which means Earth has a magnetic field, and we said that if charge moves in a magnetic field, then it gets affected because of the magnetic field. And earlier we have said that ionosphere consists of charged particles, charged ions, and electrons. Therefore, in the ionosphere, there has to be some effect due to the magnetic field of the Earth. That is what we are going to consider. Since we are going to consider that, this was an introduction or to that portion. From this we'll proceed further. So let us take a break. Stretch your legs, stretch your hands. If you have any doubts or think of it, keep it writing, and we'll discuss that after the class, at the end of the class. So let us take a break of 5 minutes. We'll come back after 5 minutes. पानी दो बेस समय होला डेरे आरंभ होला 10 मिनिट डेरे आरंभ होला ना
ଆମ ଏଷ୍ଟିମେସନ ହିସାବରେ 3:10 ରେ ସରିବା କଥା ଥିଲା ପଡ଼ିଗଲା
हां 3:14
ସରିବ ଠିକ ମାନେ
କେତେବେଳେ ଆରମ୍ଭ କରିବା କହିବ
ଆଜ୍ଞା ଏଟା ଖାଲି ସରିଯାଉ ମିଛଟା ନିୟର ଇକ୍ୱେଟର ଟାଇମ ଷ୍ଟାର୍ଟ ହଁ ସରିଯିବ ମମି ସକାଳ ଯା କେତେବେଳେ ହଁ
ଉଠାओ फैन टा टिके बढ़ी दे मत चार्ट पिला आसवे ना 5टा 6टा पिला आसवे जी इंटरेस्टेड जी आसवे से किए अच्छा से केतरा अच्छा 2 जन ध्रुव ये